Learning is always fun, isn't it? The industrial water system consists of many more processes. I hope you clearly remember and understood about the previous module we learned. Let us recollect it once. We have learned about sources of water, types of water in steel manufacturing industry, and also about few processes like bar screening, sedimentation, and also about equipments like clarifier, settling tank, and pressure filter. This module will enable you to get an idea about water softening and lime soda softening. Explain about ion exchange, in which we will learn resin classification, cationic exchangers and anionic exchangers, ion exchange resin, regeneration. Describe reverse osmosis, derivation, in which we will be learning about oxygen scavengers. Case study of DM plant at pH 5. Disinfection. Before learning about water softening, let's see what is water hardness exactly. Water hardness. Hardness is defined as the concentrations of calcium and magnesium ions expressed in terms of calcium carbonate. They react with soap and produce a deposit called soap curd that remains on the skin and clothes, and because it is insoluble and sticky, cannot be removed by rinsing. Thus, hard water is one that does not produce lather with soap. Measurements of hardness are given in terms of the calcium carbonate equivalent. Water is considered to be hard if it has a hardness of 100 mg per liter or more as calcium carbonate. There are two types of water hardness, temporary and permanent. Temporary hardness is due to the bicarbonate ion being present in the water. This type of hardness can be removed by boiling the water to expel the carbon dioxide. Permanent hardness is due to calcium and magnesium nitrates, sulphates, and chlorides. This type of hardness cannot be eliminated by boiling. Permanent hardness of water is removed by ion exchange method in an ion exchanger. Since it is important to remove hardness from water, we have opted the water softening process. Softening is the removal of hardness from water. This is not a required part of the drinking water treatment process, since hard water does not have any health consequences. Rather, minerals are required for taste and health. In addition to being unsightly, the reaction of hard water with soap results in excessive use of soaps and detergents. Upon heating in a heat exchanger, unlike other solutes, solubility of soluble minerals decreases with rise in temperature. As a result, they precipitate on inner surface of tubes, forming scale. This scale is very non-conductive to heat transfer and decreases overall heat transfer from heat exchanger. This may result in overheating of tubes that can cause tube failure. So, there are few processes by which softening of water can be done. There are three types of softening treatment: chemical precipitation, lime soda softening, zeolite process, and reverse osmosis. The first process in water softening is lime soda softening. Have you ever learned about lime soda softening? If no, let's learn it now. In this process, calcium and magnesium ions are precipitated by the addition of lime and soda ash. Following are the reactions that take place in this process. Kindly note down them. Calcium hydroxide, when added to carbon dioxide, gives rise to precipitated calcium carbonate and water. Calcium hydroxide, when added to calcium bicarbonate, gives rise to precipitated calcium carbonate and water. Calcium hydroxide, when added to magnesium bicarbonate, gives rise to magnesium carbonate and precipitated calcium carbonate and water. Calcium hydroxide, when added to magnesium carbonate, gives rise to precipitated calcium carbonate and magnesium hydroxide. Calcium hydroxide, when added to magnesium sulfate, gives rise to calcium sulfate and precipitated magnesium hydroxide. Let's go deeper into the process. Lime addition removes only magnesium hardness and calcium carbonate hardness. If you see in equation number 5, magnesium is precipitated. However, an equivalent amount of calcium is added. The water now contains the original calcium non-carbonate hardness and the calcium non-carbonate hardness produced in equation number 5. Soda ash is added to remove calcium non-carbonate hardness. Sodium carbonate, when added to calcium sulfate, gives rise to calcium sulfate and precipitated calcium carbonate. Keeping the equations in mind, to precipitate calcium carbonate requires a pH of about 9.5 and to precipitate magnesium hydroxide requires a pH of about 10.8. Therefore, an excess lime of about 1.25 milliequivalents per liter is required to raise the pH. The amount of lime required is equal to amount of carbon dioxide in milliequivalents per liter plus carbonate hardness in milliequivalents per liter plus magnesium ion in milliequivalents per liter plus 1.25 in milliequivalents per liter. The amount of soda ash required is equal to non-carbonate hardness in milliequivalents per liter. After softening, the water will have high pH and contains excess lime and also magnesium hydroxide and calcium carbonate that did not precipitate. Recarbonation, that is addition carbon dioxide, is done in order to stabilize the water. The excess lime and magnesium hydroxide are stabilized by adding carbon dioxide, which also reduces pH from 10.8 to 9.5. Carbon dioxide, when added to calcium hydroxide, gives rise to precipitated calcium carbonate and water. Carbon dioxide, when added to magnesium hydroxide, gives rise to magnesium carbonate and water. Further recarbonation will bring the pH to about 8.5 and stabilize the calcium carbonate. Carbon dioxide, when added with calcium carbonate and water, it gives rise to calcium hydrogen carbonate. It is not possible to remove all of the hardness from water. In actual practice, about 50 to 80 mg per liter will remain as a residual hardness.